All right, folks. Last notes of the first 9 weeks. Okay, so in this video, we are going to be getting into something called L'Hopital's rule. Some texts, I don't know, I feel almost confused, but they will call it L'Hospitals. I don't know. But know that if you are searching for it, some places call it both things. I do believe it is L'Hopital's. I do believe that is correct. But what this allows us to do is when we have things in indeterminate form, so when we have something like a whole, or we have something in infinity over infinity, we can use L'Hopital's rule, which is essentially saying that if I have f over g, the limit of that, and it comes out as 0 over 0 or infinity over infinity, instead of factoring or thinking about which one's the bigger one, we can actually take the derivative of the top and the derivative of the bottom. This is not quotient rule, not quotient rule, not quotient rule, not quotient rule, right? Notice derivative of f, derivative of f. Derivative of g, derivative of g. This is not the quotient rule. Do not think that this is the quotient rule. This is not the quotient rule. Do not do that. But we can use this to help us rewrite this in a different form so that hopefully it makes finding the limit a little bit easier analytically. So again, we want to use this when this is in one of these indeterminate forms. That is the time when we are going to want to use this. You'll get into BC calculus next semester, and you will see other things that we can do for other indeterminate forms. These are not the only indeterminate forms, but these are the ones that we will talk about in this class. So this condition has to be met in order for us to use L'Hopital's, though. So these are going to be a pain in the butt if you have to do this by hand for a free response question. So most likely you're going to see this in a multiple choice part for us. We may throw you one free response because we have to show that they either both go to 0 in the numerator and denominator, or they both go to infinity. Then we can use L'Hopital's to help us evaluate the limit. So let's just jump in, right, and take a look. This one, right, this one is one that we could factor the top, and we have a whole here, but let's substitute -4 and see what happens. So if I try to do the limit as x approaches -4, this would be 2 times -4 squared plus 13 times -4 plus 20 over -4 plus 4. This would lead to, oh, no, don't put the limit. Mr. Pike, what are you doing? Don't put the limit. You already evaluated the limit. Don't put numbers. Right, so this would equal this when I substitute the numbers in, which would lead me to, what is that? 32 minus 26, 52 plus 20 over 0, which would lead me to 0 over 0, which is indeterminate. So I have reached to something that is 0 over 0. 0 over 0 is indeterminate. What I need to do now is say, well, I either need to rewrite this stuff, or I can use L'Hopital's. Fingers crossed. So what I need to do is I'm going to say, not log, what are you doing? Let f of x be the numerator, and let g of x be the denominator. Since the limit as x approaches -4 of f of x equals 0, and the limit as x approaches -4 of g of x equals 0, the limit as x approaches for -4 of f of x divided by g of x is indeterminate. By L'Hopital's rule. All right, so now I'm going to say that I'm using L'Hopital's rule right there, that this limit equals x approaches -4 of derivative of the top would be 4x plus 13 and the derivative of the bottom would be 1. So now I can actually put in negative 4, which when I do that, I would have 4 times negative 4 plus 13 over 1, which is negative 16 plus 13. So by L'Hopital's rule, the limit as x approaches negative 4 of f of x divided by g of x is equal to negative 3. That's really the big thing that we're going to be looking for. Again, it is a pain because on the AP test, they're looking for all of that information. They're looking for you saying that you are using L'Hopital's rule. They're looking for you saying that each of them individually, you have to show each of them individually. You cannot do just like divided by. Super annoying. But they need all of these 3 things right there stated. They need f of x is 0, g of x is 0. They need to know that this is indeterminate. Then they need to know that you're using L'Hopital's rule to evaluate the limit. This is such a pain in the butt, but they have done this on a free response question in the past. So if you see this free response, if you see this free response, if you see this free response, you need to show all 3 parts. Okay, I'm not going to continue to do it because most likely you're not going to see this free response, but if you do, this is what you need to show. So make a big note, whatever you need to do in your notes, highlight, star, whatever, this is what you would do. All right. So moving on, so let's see, if I put in 1 ln of 1 cubed over 1 squared minus 1, well that's 0 over 0, right? Also, on this stuff, do not show me equal signs. If you are saying that it equals 0 over 0, that is not true. It makes me believe that this is 0 over 0, but remember the limit is x is approaching 1. It's not what it actually is at 1. It would lead me to believe 0 over 0, but it is not. So all that this does is say by this stuff, I need to use L'Hopital's rule. So then by L'Hopital's rule, so I'm going to go ahead and erase this stuff because I'm going to act like this is a multiple choice question. The limit as x approaches 1 of the derivative, which would be 1 over x cubed times 3x squared, all divided by 2x, which is equal to, if I rewrite this, well, I really don't need to rewrite this in this case. I could, but I don't need to. Right, this would be 1 times 3 over 2. So this would be equal to 3/2. Yay, I've evaluated with L'Hopital's, even though I cannot factor anything out here. There was a hole and there is a removable discontinuity there because that those 2 things divided by each other was 0 over 0, which is an indeterminate form, but no factoring to be done. Okay, so again, if I see what it is, again, I always try to evaluate these things to see what they are first. So arc sine of 0, that is 0 pi over 0, so that is indeterminate form. So no longer do I need this information. I've decided this is indeterminate form, so I'm going to use L'Hopital's rule. So limit as t approaches 0 of 1 over square root 1 minus t squared, all divided by 1. So now if I put in 0, this is 1 over 1 over 1, so this whole thing is just 1. So L'Hopital is going to make your life a lot easier. All right. So let's see, as I approach infinity, so this would yield e to the infinity over 2 over infinity, which would yield infinity over infinity. Right, so I know the one on top is going to be bigger most likely, so this is probably just going to go to infinity, but let's use L'Hopital's and see what happens with this one. So if I do L'Hopital's, the limit as x approaches infinity, this would be 1/2 e to the x over 2 over 1, which again, yeah, leads me to believe that this is infinity. If I substitute infinity for my x spot up here, that's e to a power that's just going to be increasing, increasing, increasing. So that should be going to infinity. There's really not a whole ton of variation to these things until we get to this last problem down here, and then then we'll run into an issue. All right, but here, I don't necessarily need to use L'Hopital's here, right? I should know that my answer is 3 over -5, so it should be -3/5, right? As they go out forever, it's going to go to that horizontal asymptote. But let's show you how L'Hopital's works with this one. So if I put in infinity, this would be infinity over infinity, which would yield an indeterminate. So I'm going to say I'm going to do L'Hopital's. By L'Hopital's, this is the same thing as the limit as x approaches infinity of 6x plus 4 over 6 minus 10x. Well, hey, if I put in infinity right now, this still yields infinity over infinity. So the big thing that I wanted you to see here is that you can continue to do L'Hopital's as many times as you need to. As long as you are still getting an indeterminate, you can use L'Hopital's. So this would be 6 over -10, which we know will reduce to -3/5. I would never do that problem like that because, like I said, you're just looking at the horizontal asymptote here. But I wanted you to show you guys that you can use L'Hopital's more than once. You just have to check that you are still getting indeterminates. All right. So now, I think this is our last one. This is the hardest one. Sweet. There's really not too many variations to this, not many applications like of how we would use this in a word problem or anything. This is as hard as they're going to get on the AP test, and this is probably the hardest one that you would see in our classes. So let's see. If I put in infinity, yeah, this would be infinity over infinity, which is an indeterminate form. So let's use L'Hopital's, right? Oh yeah, let's use L'Hopital's. So L'Hopital's would tell me that the limit as x approaches infinity of 2x over, so now here's the thing, you got to do the chain rule, right? So I come up with this. So now I can turn this into 2x, yeah, 2x times 2 root x squared plus 1 over 2x. I lied. This is not the problem that I thought it was, right? Because those two x's will divide. So if I put in infinity as it is right now, this thing is going to go to infinity. Give me just a minute. I want to find a problem that we have an issue on. Never mind, I'm lying. What I was thinking of was a BC concept. Okay, so that's pretty much as hard as it's going to get, right? Just remember, probably the biggest thing is that you can do L'Hopital's twice. Another thing we can do, if you wanted to, right? Say I had something that was like, something like this, right? Where I put in infinity and it becomes infinity, and I can't necessarily use L'Hopital's as is. However, I can rewrite this such that now it's infinity over infinity, and now I can use L'Hopital's, right? So if I put in infinity, this will be infinity over infinity, which is indeterminate. So that's no bueno. And now if I use L'Hopital's, I can approach infinity and make it 1 over e to the x, which I know will go to 0 when I put in infinity. So know that that is a possibility. Even if this was a positive x, right, positive x, I can make it a negative x down here, negative x down there. So this would actually end up going to infinity, because then you'd want to move it back up. Yes, but that would have gone to infinity there anyway, so that doesn't really matter that much. But know that you can rewrite these things however you need to. Other than that, that's all I got for you guys today. Let me know what questions you have. Have a happy weekend if you are watching this on Friday. Hopefully you are. Or if it's Sunday night, hey, I hope you had a good weekend whenever you're watching it. Bye!